Just imagine that you are moving in the opposite direction to this pen. You would feel like that it's faster than its actual speed. Now, again, if you move in the same direction and in the same speed of this pen, you would feel like that this pen is at rest, even though it's moving. Now, you may say that I can just observe the surroundings and just know that it's a motion. But just imagine that you're in blank space. There is nothing else other than you and this pen. And you and your pen are moving together. So you won't be able to notice if this pen is moving or not. This phenomenon is known as relative velocity. Before understanding that, we first have to learn about distance, displacement, velocity, and frame of reference. Now, let's first start off by first understanding about distance. Distance is the length of path traversed by the body to move from one point to the other. For example, you want to move from this point to this point. There can be only two paths that you can use. So this path as well as this path can be termed as distance. Now, what is displacement? Displacement is the shortest distance between 2 points. So this path is termed as displacement. Now let's learn about velocity. Like speed is the rate of change of distance, velocity is the rate of change of displacement. Its SI unit is meter per second. Now let's learn about frame of reference. A frame with respect to which an observer observes the position and motion of an object is known as frame of reference. For example, if an observer observes the motion of a car while standing on Earth, then his frame of reference is Earth. This is just a rough diagram, so please do not mind it. Now we can finally learn about relative velocity. As we have already discussed in frame of reference, some physical quantities are frame dependent. For example, velocity of an object inside a moving car is zero with respect to an observer inside that car, which is a frame of reference. Now, if we change the frame of reference to Earth, and let's just imagine that there is this guy called A who is seeing that this car is going downhill. So he will obviously be knowing that this car has a velocity except zero. While this guy named as B, which is inside the car, will feel like that this car isn't moving. This guy is moving ahead. This is what we call as relative velocity. Now let's do some questions to clarify our concept. Let's start off by finding the velocity of the car with respect to the man A. Now to find that, we have to subtract the velocity of car with respect to the velocity of man. Let's just imagine that the velocity of car is 5 meter per second, and as you already know that the velocity of man is 0 meter per second as he's just standing, right? So it would be 5 meter per second with respect to the man A. This is also known as relative velocity, right? Now just imagine we need to find the velocity of the car with respect to the man B. To do that, we have to subtract the velocity of car with respect to the velocity of man B. And as the velocity of car is the same as the velocity of man B, it would be 0 meter per second. Thank you.